Okay, so today is our last day of Unit 1. And as promised, we're going to get into something that many people haven't seen before. Something that was pretty commonly taught in middle school when I was there, but from what I understand, it's not such a common topic anymore. Or if you have seen it, you probably haven't seen it in the detail we're going to look at right now. So we've talked about in our numbering system, place value. And our numbering system is what is called an absolute place value system. Where we have digits that have a value, and that's the 0, 1, 2, on up through 9 is our digits. And then we have the place value that are multipliers. And again, that is depending on where they are in the number. You know, this is the times 1 place value, times 10, or 10 to the 1, times 100, times 1,000, times 10,000. So the value of a single digit, of a single item number, is a combination of the digit and the place value modifier. So a 2 located here has that value, as we've said, of 2 times 10,000, or 20,000. Doesn't matter what digits are in any of those other places, that 2 in that place will always have that value. Well, today we're going to talk about a relative position place value system. And in a relative position place value system, the value of a digit, we have digits that have their values, but then the multiplier of that digit depends on its location relative to other digits. Now, because we're so used to seeing our number system set up with the absolute place value system, we don't use our own digits for this. The digits that fit into this are the Roman numerals. And so the first thing we need to do is look at our Roman numerals and what they represent. And where Roman numerals came from, the origin of Roman numerals came from tallying. So if you're counting, you've probably all seen it done or done it yourself. You just do tallies 1, 2, 3, 4. Now we're used to doing this for 5, but originally when tallies were done, it looked like this. 1, 2, 3, 4. Then the fifth one was a V to mark that that was the fifth one. And then 5, 6, 7, 8, or 6, 7, 8, 9. Then to mark that it was the 10th one, it was an X. And then we just kept going like that. At one point in time, counting much above 15 or 20 was really kind of unheard of. So they didn't need a whole lot more than those indicators like that. So in the Roman numeral system, they started out their system by adopting those tally marks. So the regular tally mark, just the single slash, or the capital letter I, became 1. And then the V represented 5. And the X represented 10. And for the longest time, that was really all they needed. They could express numbers up to about 38 using just those digits and the rules they'd established. But over time, of course, there became a need to express larger numbers. And as that became necessary, they brought in digits that had other meanings. For example, the Latin root centi means 100. So C was 100. Now, in order to get from 10 to 100, there's a big gap there, so they defined another digit for 50, which was the L. And I've never been able to find a good explanation of where the L came from. One of them was that as the tally system grew, that when you hit 50, the tally for 50 was an L. I haven't been able to confirm that with other sources, though. But the C definitely came from centi. Getting larger than that, we needed one for 500. That was D. And then M, mil or milli, stood for 1,000. So M was 1,000. And if you have learned Roman numerals before, those are the ones you've probably seen before. 1, 5, 10, 50, 100, 500, and 1,000. There are other numerals that are commonly used in the medical fields. One of those is the digit for 1/2. And that is two small s's. SS stands for 1/2. Some textbooks will tell you that the largest digit that can be expressed with standard numerals is 389 or something like that, or 99, or 3,999. They are losing sight of the fact that there are digits, as they became necessary to be larger than 1,000. Rather than come up with more symbols, what they did was used a bar. So X with a bar over it, actually I should do the V with a bar over it first. V with a bar over it was V times 1,000, or 5 times 1,000, which was 5,000. X with a bar over it, well, X was 10. The bar meant times 1,000, so that was 10,000. And that system went all the way up. L with a bar was 50,000. C with a bar was 100,000. D with a bar was 500,000. And then, of course, M with a bar was 1,000 times 1,000, or 1 million. And so 1 million was the largest digit. I mean, in these times, in the Roman times, comprehending something larger than 1 million was almost an incomprehensible size for them. So where the relative position place value comes in is the Roman numerals could either be additive or subtractive. So what the additive system meant was to get to a number like 3. We didn't have a numeral for 3, we just had numerals for 1. And so to create 3, it's just 3 i's, 1, 1, 1, which stood for 1 plus 1 plus 1, adding up to the 3. By the way, as a side note, I was always taught that the Roman numerals had to be capital letters. Again, it was much the same reason why I was taught that liter had to be a capital L as the abbreviation. It's just for ease of reading. It's usually easier to read capital letters, harder to make them sloppy and hard to see. But it is okay to use small letters for our Roman numerals. If I had something larger that I wanted to represent, let's say I wanted to represent the number 7, I'd use VII. That was 5 plus 1 plus 1 equals the 7. The values of the digits were added together. As long as the digits went from larger to smaller. So if we look through these, V is 5 and then I is 1. The larger digit is first, followed by smaller digits. So we never have a smaller digit in front of a larger digit. So that'll mean it'll always be additive, adding the values. But to express something like a 4, the Romans decided that having I was too clumsy. Having 4 I's in a row just didn't work. So rather than doing that, they introduced a subtractive property. And the subtractive property was when a smaller digit appears in front of a larger digit. So IV, because I is smaller than V, I is 1 and V is 5, this is a subtracted digit. And so what this is saying is these two digits work together to be 5 minus 1, or 4. So that represents the 4. They only subtract ones, tens, and hundreds. They do not subtract 5s, 50s, and 500s. Not sure why. The one reason I've shown why makes a lot of assumptions. For converting digit by digit into our Arabic numerals, is what our numerals are called. It's easier if you don't. But they were thinking almost in terms of place values even back then, of saying we're only going to subtract those powers of 10. The 1, 10, 100, and even then 1,000 when you got up into the larger digits. So if I wanted to express a number like 46, what they did was they represented it digit by digit. Now again, they didn't have Arabic numerals yet, so saying that they expressed it digit by digit is assuming a knowledge of numbers that didn't exist yet, but it's the easiest way I can explain for how we stay true to their rules. So we'd express the 40 first. Well, 40 would be expressed as 50 minus 10. So that would be XL. L is the 50, and since the X is 10, it's in front of it, it is subtracted. So that's the 40. And then to represent the 6, well, that's just VI. 5 plus 1. Since the 1 is after the 5, it's smaller is after larger, so those are added together to give us the 6. So that is our 46. So because the fact that they only subtracted the 1s, 10s, and 100s shows that they did have some precursing knowledge of place values and the value of the power of 10. They just didn't quite put it into practice as they were filling out these numbers. So let's take a look at some larger numbers. Now, like I said, they only subtract the 10. One of the common mistakes, and be careful, don't write this down because I don't want you to accidentally make this mistake. One of the common mistakes that is made using Roman numerals is to look at that and say, well, that would be much easier to say 50 minus 5, so VL and then plus 1. 50 minus 5 would be 45 plus 1, but like I said, they just don't use the 5s, 50s, 500s in that subtractive position. So that is not proper Roman numeral. So let's look at something like 389. So again, when we convert from our standard numerals, or what we call Arabic numerals, which is what we use, to Roman numerals, the simplest way to make sure we don't have an issue is to go digit by digit. So this 3 represents 300. To represent 300 in Roman numerals, it is simply C, C, C. Well, next we have the 8, which represents 80. To represent 80 in our numerals, or in the Roman numerals, it would be 50 plus 10 plus 10 plus 10. So 50 would be L, and X, X, X. Notice that's allowed because there's no more than 3 of the same digit in a row. We have 3 C's in a row, that's fine, we just can't have a 4th one. We have 3 X's in a row, again, that's fine, we just can't have a 4th one in a row. And then we want to represent the 9, which does just represent 9. We can't have VIIII because that would be 4 1s in a row. But here we have to use the subtractive IX. Since the 1 is first, it's 1 subtracted from 10 to give us the 9. Now you might say, well, there's a 4th X there, and that's true, but it's not 4 X's in a row. We can have the 4th X as long as they're not consecutive. So let's look at 2,994 as to how we would then convert that into our Roman numerals. So we start with the 2, which is 2,000. So to code 2,000, the symbol for 1,000 is M, so we just use MM for 1,000 plus 1,000. Next, the 9 here is 900. Well, again, 900, we can't do 500 plus 4 1s because 4 100s would be 4 in a row. We can't do that. So the way we have to do the 900 is to do 1,000 minus 100. And to do that in Roman numerals, it's CM. C is the 100 subtracted from the 1,000, the M. The next digit is also a 9, but that 9 is representing 90. Again, we can't represent 90 as 50 plus 10 plus 10 plus 10 plus 10, because again, that would be 4 10s in a row. We can't do that. So the way we have to express 90 is 100 minus 10. And the way we do that, of course, is X is 10 from C, which is the 100. And then finally, that last digit of a 4 is just 4. And we represent 4 as IV. So as you're catching up on your notes for that, just a couple little comments. One, there's a lot of slang in our current and English vocabulary that come from Roman numerals. One of those is the term C note. Well, a C note is just a $100 bill because C represents 100. The other interesting little bit of trivia that comes from Roman numerals is you hear of the Ivy League. And most people mistakenly think it is Ivy like that, which was Harvard, Cornell, Brown, and Yale colleges. And most people think ivy comes from the plant, the ivy vines that grow on the walls at most of those institutions, but that is not correct. Ivy comes from the fact that there are 4 of them, which is literally the Roman numeral IV. So it's not really the Ivy League, it's the IV League, is what that refers to. Okay, so hopefully most of you are caught up on your notes at this point. So I'm going to have you try to code one here. So we are going to do 1,799. So I'm going to have you go ahead and try to code that. So the first digit, the 1,000. That one's pretty simple, straightforward. It's an M for 1,000. Second digit is 7, stands for 700. We can do 700 as 500 plus 100 plus 100. That's no, there are no spots where we need more than 4 symbols, so that is just fine. So the 7,000 or 700 would be 500, which is D plus 100 plus another 100, so CC. The next digit is the 9. It's in the tens place, that stands for 90. 90 cannot be done additively. 90, it would be 50 plus 10 plus 10 plus 10 plus 10. That would give us 4 tens in a row, so we can't do that. So we would have to do that subtractively as 100 minus 10. So it's XC, 10 from 100. And then the same is true for this last digit, the 9. 9 cannot be coded as 5 plus 4 plus 4 plus 4. It has to be coded as 10 minus 1. So it's IX. As long as you go digit by digit like this, you will get the correct Roman numeral. Where people make their mistakes is if they try to look at the bigger number, the whole number, and do it all at once. Because one of the common incorrect codings of this would be MDCC, that's the 1,700, and then just do IC. Well, this would be 100 minus 1, which would be the 99. But that would be coding both of those last digits at once. And they never did that. They never subtracted more than what we called one order of magnitude smaller. So if they have the main number of 100, they didn't subtract anything smaller than 10 from it. So they couldn't do 100 minus 1 because that was too far. It's 2 orders of magnitude away rather than just 1. So be careful. Do it like this, digit by digit, to get the correct Roman coding. Let's go the other direction. Let's take the Roman numerals and put them into our standard notation, our Arabic numerals. So something as simple as this, XXXIV. First thing we need to do is go through and identify which digits are positive and which ones are negative. So first of all, X here has no smaller digits in front of it, so that's good. And the digit that comes after it is the same size, so that means that's a positive digit. I'll make that in blue for positive. And then next we have the X, next X followed by an I, which is a smaller digit, which means that X has to be positive. The I here, however, is followed by V, which is a larger digit. That's telling us that I has to be a negative digit. Of course, the V is the end of the number. The last digit of the number is always a positive digit. So when we convert this, what we are seeing is we have 10 and 10, 10 plus 10. Then this is when we have the smaller digit in front of the larger digit, they work together. That is 5 minus 1, or 4. So 10 plus 10 plus 4 is 24. A symbol we have not used yet would look like this. Like I said, it is okay to use small digits instead of capital digits. So here we have the I, which is 1, followed by the V, which is 5. So since that is a smaller digit in front of a larger digit, that 1 is being subtracted. That is a negative. So the V is a positive, but it works with the 1. So this is the 1 and the I and the V work together. Be 5 minus 1, or 4. SS, even though it's 2 letters, it is a single value. That is 1/2. So that codes to be 4 and 1/2 in our Arabic numerals. Let's take a look at this one here. So again, M is followed by another M, so that's positive. It's followed by a digit the same size. This M is followed by a C. The C is smaller, so that M is also positive. This C, however, is followed by an M. It's followed by a larger digit, so that tells us that C is subtracted. It's a negative. This M has to work with the C, so those two are going to be combined together. This X is followed by a C. The X is 10 and that C is 100. So that means this X is subtracted. And of course, it has to work with that C. Then the V is followed by an I, so the I is smaller, so that's positive. And then the 3 I's are all the same, so they're all positive. So when we go to code this is 1,000. This is another 1,000. Line that up a little better. This is CM is 1,000 minus 100. That would be 900. XC is 100 minus 10. That would be 90. And VIII, that's 5 plus 1 plus 1 plus 1, which is 8. So you can see that is 2,998. I'm going to give you one to try in your notes. See what you come up with here. MCCC XCIX. I'll give you a minute, then we'll go over that. So again, the first thing we should do is check to see which digits are positive or additive and which ones are being subtracted. So this M is followed by a C. Remember, the M is 1,000 and C is 100, so it's followed by a smaller digit. That's positive. This C is followed by another C, so they're all positive because they're all the same size. The X is 10 and the C is 100, so that's followed by a larger digit, telling me that that X is a subtracted digit, and it's going to work with the digit that comes after it. The I is 1 and X is 10. So again, that's followed by a larger digit, which tells me that that I is subtracted, and it is going to work with the digit that comes after it. So M is 1,000. C works together, 100, 100, 100. XC is 10 from 100, or 100 minus 10, which is 90. And IX is 1 from 10, or 10 minus 1, which is 9. So we have 9, 9, 3, 1. 1,399. And we might have something like this. I'll give you a minute to decode that one. So again, we need to figure out which digits are positive, or if any of them are subtracted. The X is a 10 followed by I, which is 1, so the X is positive. The I is 1 followed by V, which is 5, so that's followed by a larger number, so that I is subtracted, and it has to work with that V that comes after it. SS, of course, is 1/2, so that is fine, then just one digit works together. So X is 10. IV is 1 from 5, or 5 minus 1, which is 4. And SS is 1/2, so that is 14.5. That adds up to. So as you were working on that, I wrote this next one over here. So this one takes advantage of that bar notation that we had mentioned. So again, I'm going to go through and see what each digit represents. That V bar is 5,000. It's followed by an M, which is 1,000, so we know that that V bar is a positive digit. M and M are the same size, so those are both positive or additive. D is 500, followed by C, which is 100, so the D is positive. The C's are all the same size, so they're positive. X is followed by C, so X is 1 or 10, C is 100, so it's followed by a larger digit. So that tells me that X is negative, it's subtractive, and it goes with the digit coming after it. Then we have V, which is 5, followed by I's, which are 1. So those are all positive. So as I said, we have the V bar, which was 5,000. M, which is another 1,000. Another M, which is another 1,000. D is positive, that's 500. C is 100. Another C is another 100. And another C is another 100. XC is 10 from 100, 100 minus 10, which is 90. And V, 5. And I is 1, and another I is another 1. So we add those up, we have 7, 9, 8, 7. 7,897. Now, when we add with Roman numerals, they didn't do a whole lot of subtracting with their numerals, but they did mostly adding. It was, like I said, it was kind of based on the tally system of adding things up. They didn't really work backwards going in the other direction. So if they wanted to add in Roman numerals, it was a matter of simply combining the digits and then regrouping if necessary. So if we had an M, CM, LXXI plus MMCC XCIV. Now, if we really wanted to, we could convert these into our Arabic digits and then convert them back into Roman numerals. In fact, we're going to do that after we've done this, just to make sure we did it correctly. But again, this comes down to the first step is identifying if any of these digits are subtracted. So the M is 1,000, C is 100, so M is bigger, so it's added. But we got C followed by M. C is 100, M is 1,000, so that C is subtracted, and it has to combine with that M. L is 50, followed by X, which is 10, so that L is added. Two X's in a row, so they have to be added. And of course, the last digit is always an additive digit because there's nothing after it. So the only negative digit here is the C. Now, the fact that the C works with the M is important if we were converting this. But if we're adding, we can treat that C by itself for the most part. And I'll show you once we decode the next number. So here we've got M and M, so those are both positive. CC, you may have noticed a pattern. Anytime two digits of the same digit is repeated, they're both positive. X is 10, followed by C, which was 100, which is telling me that X is subtractive. And technically it works with the C. Again, we're going to treat that subtractive digit by itself as we combine here. The I is 1, followed by V, which is 5, so that I is subtractive. Again, technically it works with the V, but we will treat it by itself. So those digits that are circled in red are subtractive digits. So what that means is I can actually cancel out a similar digit from the other number with that digit. So here I have a red C that's negative. I'm going to cancel out one of the positive C's from the other number. I have a red X here that's subtracted, so I'm going to cancel out one of the X's from the other number, one of the positive X's. And I have a red I here. I'm going to cross that out and cancel out an I that's positive from the other number. Now we just go ahead and combine symbols. So I have 1, 2, 3, 4 M's. Now I realize that's improper Roman numerals at this point, but we'll come back and we'll deal with that in a minute. So I've got the M, 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 and M. I have two C's here, so C, C. Got those. I have L, I have X, and I have V. So I just list the remaining numerals from largest to smallest. And now I do have to regroup. I have to check to see if there's any spots where there's more than 3 in a row. And we saw that right away. Here we have 4 M's in a row. Now, M, 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 M is 1,000 plus 1,000 plus 1,000 plus 1,000. That's 4,000. Well, the way we would represent that is 1,000 from 5,000. Remember, 5,000 is the V bar. And then the rest of the digits are just going to stay the same. C, C, L, X, V. So this is 4,265. So that round comes up to be. If I were to decode that, this is 4,000. This is 100 plus 100 is 200. 50, 10, and 5. 4,265. Well, let's decode the original numbers just to make sure we get the same result if I convert them to our standard numerals and back again. So again, I'll go back to grouping the ones that go together. So this digit here, this first one, this is 1,000. This is 1,000 minus 100, or 900. 50, 10, 10, and 1. 179, 1,971. This one here, this is 1,000 and 1,000. 100 and 100. Now the XC, that's 10 from 100, or 90. And IV is 1 from 5, or 4. 4922, so that's 2,294. If I add 1,971, 2,294 in our standard numerals, 5, 6 carry the 1, 2 carry the 1, 4,265, which is exactly what I had combining the Roman numerals. I'll leave it up to you whether you want to actually try to do the combining of the numerals like I did up here, or if you just want to do the converting to standard numerals or Arabic numerals, add them together and convert them back. There will be one problem on the test on Wednesday where you do have to add Roman numerals. Well, like I said, you can convert them to our Arabic numerals and then convert them back when you're done, or you can actually try to combine them like we did here. So now with that, remember, test 1 is on Wednesday. For that test, you may use your books, your notes, and your calculator. If you are using a cell phone for a calculator, you just can't use any apps or anything like that other than just the calculator app. The big thing, though, is even though you can use a calculator, problems 1 through 13, you must show your work. So as we mentioned before, that's if you're dealing with fractions, that's finding the common denominators. Dealing with Roman numerals, that's, if you're converting it back, show your conversion. Just show your work so that I know that even if you did use the calculator to check your answer, you know the process. With that, then homework for today. In your book, page 39, 1 through 12. Again, you'll need most of that to practice. Most of us are not terribly familiar with Roman numerals. Also, for the test on Wednesday, we are only taking 1 class hour to do the test, so 50 minutes, 46 minutes. But you are allowed more time if you need it. So if you need more time than that to finish the test, this first test usually doesn't take that long. But if you do need more time, arrange it with your person at your school, and you get more time. The only condition I have is it has to be completed and sent back to me by Monday's class time. So you have the rest of the week to finish it up. It just cannot leave the classroom. It has to be done with supervision at your school is all, the only requirement. So with that, does anybody have any questions? Okay, so we will see you on Wednesday. I'll be logged in case there are questions during the test. But on Wednesday, all we will be doing is the test. Your contact person at your school does have that, so they will have that available for you. If you come into the classroom and you don't see it, go and ask whoever is your contact there for it, and they'll get it to you. All right, you guys have a great day, and we'll see you on Wednesday.